Hi everyone, I am Hina Wajid and I have passed my ARDMS exam with 94% marks in SPI and 94% marks in OBGYN. Now here on YouTube, I share SPI related MCQs and tips to help others pass ARDMS exam too. If you want full SPI session and all topics explanation according to ARDMS content outline and their syllabus, then you can find the link in the comments to check some of the free PDFs, some of the free videos, and you will also find details how to contact us to join our complete session. Okay, very good. So what is the Nyquist limit? Nyquist limit is the maximum velocity you can measure without aliasing. So it's a system upper limit which determines the maximum Doppler shift that can be measured without aliasing. So you can adjust the Nyquist limit by changing the scale. What is the scale? Like velocity range which we can measure is a scale, and upper limit of the scale is aliasing. Increasing the scale increases the Nyquist limit, decreasing the scale decreases the Nyquist limit. So increasing the scale is just like widening the speed limit on a highway. You can now measure fast moving cars, higher shifts without missing them. So when we raise, when there is aliasing, we increase our scale. So aliasing then corrects. So here we can see the upper limits of the positive and negative channel, +4 and -4. So this is our Nyquist limit. So if our Doppler shift exceeds the Nyquist limit, then what happens, Dr. Awadia?
Aliasing artifact or wraparound.
Yes, then aliasing a wraparound artifact happens. What is the cause of the aliasing? Tesveen?
This is because, for example, if the Nyquist limit is too low, then it actually causes aliasing.
Okay, so low PRF, low scale, low Nyquist limit, these are the causes of the aliasing. So it's like if your speedometer only shows up to 120 km per hour, what happens if you drive at 150? You cross the limit, needle wraps around, that's aliasing. So also in the spectral Doppler, when you cross the limit, then Doppler shift cross the limit, then what happens? There is aliasing, the wrap around. Flow is displayed in the negative channel. Okay, now waveform analysis. So Doppler shifts in the waveform are positive, means flow is toward the transducer. The waveform is phasic, mean it has a repeating cycle of higher and lower Doppler shift, which is typical of arterial blood flow. We will discuss in hemodynamics. Monophasic, biphasic, triphasic, different waves. So it's just like watching a tide coming in, higher shifts and going out, lower shifts. This shows the blood flow through the artery. So it's like peak, going down, peak, then going down. Usually biphasic flow is like this. So the higher shift happened during the systole, where the heart pumps and blood velocity increase, and the lower shift occurs during diastole, where the heart relaxes and blood velocity decrease. So think of it like a roller coaster, right? The fast, steep climb represent systole, higher shift, and the slower, smooth descents represent diastole, lower shifts. These are important for the MCQs. In the systole, there is higher Doppler shift, In the diastole, there is lower Doppler shift, as we can see here. Okay, Dr. Awadia, is this a biphasic waveform or a triphasic waveform?
The triphasic waveform.
Yes, this is triphasic. First we can see systole, then we can see flow reversal, early diastole, and then we can see again forward flow in the late diastole. So this type of the waveform is known as triphasic waveform. Okay, now let's discuss the MCQs. So first one is, what is the primary advantage of pulse Doppler over other Doppler modalities?
Excellent range resolution.
Okay, very good. This one, which of the following does pulse Doppler require to provide the most detailed blood flow information? Larger sample volume, low Doppler angle, high Doppler angle, continuous flow signal. That Awadia, what do you think?
A low Doppler angle.
Okay, very good. Low Doppler angle. This means, which of the following components is responsible for detecting Doppler shifts in pulse Doppler?
SBC transducer.
Yes, QPD, quadrature phase detector. B. Okay, Dr. Awadia, what is the primary purpose of the sample volume in pulse Doppler?
To isolate Doppler shift from a specific region of interest.
Okay, very good. Tesfine, what does the y-axis on the spectral Doppler display represent in pulse Doppler?
D, magnitude of Doppler shift. D or A, blood velocity.
D, magnitude of the Doppler shift.
Why the answer is not A?
So it shows how large the Doppler shift is corresponding to the speed of the blood flow. Okay, so the right answer here will be magnitude of the Doppler shift. The main thing it represents is the magnitude of the Doppler shift, and then we know that further this magnitude of the Doppler shift also tells us about the blood velocity, but also we know magnitude is a broader terminology and it depends on velocity as well as angle. So if also there is magnitude of Doppler shift in our option, then we will pick magnitude of the Doppler shift. If there is only velocity in the option, then we will go with the velocity. Okay? Because magnitude of the shift depends on the velocity, one factor, and also on the angle. So the right word is the magnitude. Okay, Dr. Awadia, what does the x-axis on the spectral display represents in pulse Doppler?
Time.
Yes, the x-axis represents time. This means, how does the Doppler angle affect the accuracy of pulse Doppler measurements?
The smaller Doppler angles increase accuracy.
Very good. Smaller Doppler angle increases the accuracy. Dr. Awadia, what is the purpose of the spectrum analyzer in pulse Doppler?
To analyze and display Doppler shift data.
Yes, to analyze and display Doppler shift data. This means, how does a strong Doppler shift amplitude appears on the spectral display?
B, brighter pixel.
Yes, brighter pixel. And on which thing amplitude depends on?
The amplitude is on the x-axis. It is shown by the brightness, is the strength of the Doppler signal.
So amplitude depends on the number of RBCs. Higher number of RBCs, higher amplitude. Lower number of RBCs, lower amplitude. So what does amplitude tells? The brightness of the waveform. Dr. Awadia, what happens if the Doppler angle is too large?
The Doppler shift become less accurate due to cosine error.
Okay, very good. Tasween, what does the z-axis on the spectral display represents in pulse Doppler?
The amplitude strength of the Doppler shift.
Okay, it describes amplitude of the Doppler shift. Dr. Awadia, what kind of flow information can pulse Doppler provide?
All of above.
Yes,
Follow
all of the
direction
above.
of the
Yes, exactly.
in R.
Exactly. Tasween, how does the spectral display show blood flow direction?
It's A. Positive shift are displayed above the baseline, negative shift below.
Okay, very good. Dr. Awadia, which of the following controls the placement of the sample volume in pulse Doppler?
Sample volume position using track wall.
Okay, very good. Tasween, what does the baseline on the spectral display separate?
A. Positive, negative frequency shift.
Okay, very good. Dr. Awadia, which of the following is not a factor that affects Doppler shift magnitude?
Sample volume size.
Okay, very good. Okay, Tasween, how blood velocity affects Doppler shift magnitude? Directly related or inversely related?
Directly related.
Directly related. Okay, good. What about the transducer frequency?
It will be lower.
It is also directly related. And what about the Doppler
Directly.
angle?
Inversely related.
Smaller, yes, yes, it directly related.
Yes, angle is inversely related. And sample volume size, it does not affect Doppler shift magnitude. This means, what happens if the sample volume is too large?
Inaccurate range resolution.
Yes, the right answer is inaccurate range resolution, because a larger sample volume can cause overlap and reduced range resolution, making it harder to analyze specific areas. Dr. Awadia, what does the receiver gauge in pulse Doppler do? Tasween, what do you think about this?
Filter out unnecessary data. Filter out unnecessary data.
Exactly, it filters out unnecessary data. Tasween, what is the effect of higher Doppler shifts on the spectral display?
C. A larger vertical displacement.
Yes, a larger vertical displacement. Higher Doppler shift results in a larger vertical displacement on the spectral display, indicating faster speed flow. Dr. Awadia, what is the typical time range shown on the x-axis of a spectral display?
3 to 4 seconds.
Very good. The right answer is 3 to 4 seconds. This is a typical display, shows 3 to 4 seconds of Doppler shift over time. Tasween, which phase of the cardiac cycle produces the higher Doppler shift in a phasic waveform?
Systole.
Okay, very good. Systole. Dr. Awadia, in phasic waveform, what produces the lower Doppler shift?
Diastole phase.
Yes, very good. Diastole. Tasween, what does the baseline on the spectral display separates?
A. Positive and negative blood flow directions.
Okay, very good. So, okay, Tasveen, can you now repeat what's described in this slide?
Okay, so pulse wave Doppler provides the details about blood flow, and usually we will apply it after using color Doppler. And basically, we need a small sample volume in the region of interest, basically in the center of the vessel. Okay, so excellent range resolutions because of the receiver. It's selective of the information. Okay, and therefore it allows detailed flow analysis.
Okay, very good. Dr. Awadia, can you please now repeat what's written in this slide?
Yes. Both Doppler instrumentation use the same transducer as for grayscale imaging. Transmit at lower frequency than grayscale imaging, higher intensity output than color Doppler or grayscale due to longer pulse and higher DRF.
Okay, very good. Tasveen.
Alright, so now basically there's only a single scan line used to detect the shape. Alright, and it appears as a white vertical line on the screen. Okay, and to ensure the most accurate results, the angle between the Doppler line and the blood flow should be as small as possible.
Okay, very good. Dr. Awadia.
For sample volume, a small region within the tissue or Doppler shift indicate by horizontal line or a small rectangle or oval adjusted by sonographer with the trackball.
Okay, very good. Tasveen.
Okay, so receiver, what receiver does is it has a gate. So now the gate actually is selective. It opens and closes at a specific time to accept that specific Doppler shift that is coming from the sample volume. Alright, so therefore, due to this, there's not much of noise and excellent range resolution because it rejects the timing codes.
Okay, very good. Dr. Awadia.
Detect Doppler shift by subtracting transmitting and receiving frequency by quadrature phase detector. Calculate the Doppler shift frequency also.
Okay, very good. Tasveen.
Okay, so the loudspeakers, it's audible, and the Doppler shift are in the low kilohertz range. Now, the pitch, from the pitch itself, you can actually know the type of flow, whether it's arterial or venous.
Okay, very good. Dr. Awadia.
Spectrum analyzer break down Doppler shift into components, frequency, magnitude, and amplitude. Analyze shift 50 times per second using fast Fourier transform.
Yes. So the technique used here in the spectrum analysis is fast Fourier transformation. This technique name is important. And what was the processing technique in the color Doppler, Tasveen?
Color Doppler.
I will give you option. Quadrature phase detector, are the fast Fourier transformation, autocorrelation, or spectrum analyzer?
Autocorrelation.
Yes, autocorrelation. Very good. Okay, Dr. Awadia. What about the spectral display?
Spectral display is the graphical representation of Doppler shift. Display shift direction, magnitude, and amplitude. X-axis in the spectral display represents time, which was 3 to 4 seconds of display. Y-axis is the magnitude, and this Z-axis is amplitude.
Okay, very good. And what about the angle, Tasveen?
Okay, so basically we want to make sure there is a smaller Doppler angle as it reduces the cosine effect errors, and larger obviously there will be more cosine errors effect.
Okay, very good. What about the Nyquist limit, Dr. Awadia?
the maximum Doppler shift frequency that can be detectable by the system without aliasing. Increase by increasing the scale, decrease by reducing the scale.
Okay, excellent. Okay, now what about aliasing, Tasween?
Okay, so basically aliasing happens when the decrease limit is low and the Doppler shift exceeds. So this causes distortion of the waveform. So basically, we can actually reduce it by adjusting PRF or increasing the scale.
Okay, very good. Now what about the phasic waveform, Dr. Awadia?
Is a show repeating cycle of high and low Doppler shift, typical of arterial blood flow with high shift in systole and low in diastole, mainly arteries.
Okay, very good. So higher Doppler shift are seen in systole, lower Doppler shift are seen in diastole.